Hi, my name is Carol Sofia Rodriguez Esquivel, and today I will present my project Volume of Paper Figures and Freefall. And my research question is, how will the volume of a paper figure affect the time it takes to touch the floor from a certain defined distance? My objectives and hypothesis, my main objectives was to prove whether the volume of a figure affects the time it takes to touch the floor, and the small objectives that I had to follow were measure the paper sheets, create the figures with paper, measure and guarantee that every object is produced with the same quantity of paper, measure and calculate the volume of each figure, measure the time each figure takes to complete the path from the top to the bottom, and compare the results and prove or refute the initial hypothesis. And it is if the volume of a paper figure is bigger, then it would take longer to touch the floor because volume affects falling object's velocity. Okay, and my justification was that terms I wanted to see terms that we reveal in physics class, such as free fall or gravity is a constant. And this experiment researches the relationship between volume, velocity, gravity, acceleration, and time. This experiment hasn't been previously elaborated, and physics and other areas such as mechanics or movement studies. And then for the introduction, I want to introduce you to some small definitions. Friction is a tangential force that opposes the sliding of an object across an adjacent surface with which it is in contact. The air resistance are the forces that are in opposition to the relative motion of an object. The volume is the space occupied within the boundaries of an object in three-dimensional space, and the area is the space inside the boundary of or perimeter of a closed shape. And then for the methodology, I used two different variables, the independent and the dependent one. The independent was the volume of the object. This one was the one that I was going to manipulate in the prisms, and the dependent variable was the time that it takes for each object, since that one was the variable that will vary through the experiment. And the materials that I used were sheets of paper, a ruler, a fluxometer, a timer, some scissors, and glue. And the methodology or the steps that I follow, first of all, I had to do the paper figures. I measured the area and calculated the volume. I only used one sheet of paper. I found a high place to do the experiment. I dropped the objects and measured the time and obtained the results, and I analyzed them. In total, the height was 3.85 meters. It was from a balcony of my house, and I dropped the objects. And the results and data collection were, first of all, I had a rectangular prism with the surface area and volume. It took 1.43 seconds. All of them traveled the same distance, and its average speed was of 2.61 meters per second. Then the triangular prism had this, all of them had the same surface area because that's the experiment. The volume of the triangular was 115.5. It took 1.4 seconds, and its average velocity or speed was 2.75. For the circular one, same surface area, and the volume was 355.36 centimeters square, and it took 1.48 seconds, and the average speed was 2.6. For the pentagonal prism, again, the same surface area, and the volume was 196.77. It took 0.9 seconds to reach the floor, and the average velocity or speed was 4.27. For the hexagonal prism, the volume was 142.12. The time was 0.94 seconds, and the average speed was 4.009. And finally, for the octagonal prism, the same surface area, and the volume was 222 centimeters square, and the time was 1.26 seconds. And therefore, the average speed was 3.05 meters per second. Then I'm going to do the data analysis. But first of all, I want to say again the hypothesis so it's clear. And it is if the volume of a paper figure is bigger, then it will take longer to touch the floor because volume affects falling object's velocity. Then the rank between the volumes is 239 centimeters square, and the time was 0.58 seconds. And there is no apparent relationship between the volume of each figure and the time it takes to reach the floor. So thus, it can be stated that this theory is incorrect and that it can be refuted after the realization of this experiment. In conclusion, there is no direct relationship between the volume of a paper figure and the time it will take it to reach the floor from a certain height, but there was variation in time and speed. It can be concluded that volume and area influence the time it takes the paper figure to reach the floor, but there is no direct relationship between volume and time. And the limitations on the project were air friction, time measurement, and precision. The three of them are related because even though I recorded a video, I couldn't use maybe milliseconds to measure the time. And well, the final two questions, what is the importance of the scientific method? For me, it guarantees results. A single format to define science, make it easier to analyze the results and easy to share and understand. And finally, what I learned from this activity is that physics are always related, how to establish a hypothesis and the importance of the scientific method. These are the sources, and thank you so much.